Hi guys, here is some notes with inequalities. Okay, so what we're going to do first is we're going to look at some of the why behind inequalities and some of the things that we do. So this says when we solve an equation, we add, subtract, multiply, or divide to both sides. Let's see if this holds true for inequalities. Okay. So what I'd like you to do is I would like you to complete each of the following operations on both sides of the inequality and circle the statements that are no longer true. For example, add 4 to both sides. 4 plus 2 is 6. 6 plus 4 is 10. And that is still true. 6 is still less than 10. What I'd like you to do is I'd like you to pause the video and I'd like you to do each of these remaining 5 problems. Right now, pause, and then when you press play again, you'll see me complete this as well. So you're going to watch me do it because I can't pause the video. So I'm going to multiply both sides by 5, and I get 10 is less than 30. That's still true. I'm going to divide both sides by 2, and I get 1 is less than 3. That is still true. I'm going to subtract 5 from both sides, and when I do that, I get negative 3 is less than 1. That's still true. I'm going to multiply both sides by negative 5, and I'm going to get negative 10 is less than negative 30. Is that still true? The answer is no. So it says circle the ones that are not true. And if I divide both sides by negative 2, I get negative 1 is less than negative 3. That's not true either, so I'm going to circle it. So what did we find? Well, we found that when you multiply or divide by a negative, you get an untrue inequality. Okay, and so how can we use this information? Well, what we could have done is if this sign went the other way, this would be a true statement. And if this sign went the other way, it would be a true statement. So this is why, and you've heard me already talk about this, but this is why we have to flip the sign when we multiply or divide by a negative number. Okay, these notes you're taking as well. Okay, so let's try using that now. So now if I use that, I've got some problems here on the back, okay? And so I'm also, you notice there's some number lines. So the first one I'm going to talk through. And remember, if you want to pause this at any moment, try it on your own, fast forward. That's completely fine. You don't have to watch this entire video and me talk through each of them. But I know some of you would appreciate that. So I've got to rearrange this equation to get x by itself. I'm going to add 5 to both sides. And when I do that, I'm left with 3x is greater than 7 plus 5 is 12. Divide both sides by 3. I haven't multiplied or divided by a negative, so I'm good. And I have x is less than 4. Okay. Well, with graphing on just a number line, you may or may not remember, if we have less than or greater than, we're going to have an open circle. If we have less than or equal to or greater than or equal to, we're going to have a closed circle. This is kind of equivalent to the dotted line versus the solid line that we've been talking about with two-dimensional graphing. So we're going to go to 4, and because this is a greater than, I'm going to put an open circle. And I need numbers greater than 4, which means up here. And that's how we graph it. Okay, let's try another one. Again, you can pause this at any time. So if you just watch this straight through, I might be going fast, but you can pause and rewatch. Same deal, minus 8, negative 2x is greater than or equal to negative 12. Divide by negative 2. Okay, whoops. Big red alarms going off. I'm dividing by a negative, which means I have to flip the sign. And a negative 12 divided by a negative 2 is a positive 6. So I go to positive 6. I'm going to put a closed circle. And this reads x is less than or equal to 6. So it's all these numbers down here. Next. I'm going to subtract 9 from both sides, and I'm left with x divided by negative 3 is less than or equal to 11 minus 9 is going to be 2. And then I have to undo this division. We're not as used to doing this, but undoing division is the same as multiplying. So I'm going to multiply both sides by negative 3, and here we go. We've got to rearrange we have to repoint our sign. And so these cancel, and I'm left with x is not less than or equal to, but greater than or equal to negative 6. And then I graph. It's an equal to, so it's a solid line, and or a filled in circle. And then I'm looking at greater than. And you can always test this, by the way. If I pick any number up here, let's pick 3. If I plug in 3, it better work because it's in the solution set. So 3 over negative 3 plus 9, is that less than or equal to 11? Well, 3 divided by negative 3 is negative 1 plus 9. Is that less than or equal to positive 11? Negative 1 plus 9 is positive 8. And yeah, that's true. And you could check a couple different answers. Okay. Last but not least, again, you're pausing when you want to try them on your own, and then you're playing when you want to watch. This one has a ton. Okay, so this is one of those ones where we're cleaning up both sides, then we're dealing with left and right. So I'm going to distribute this on both sides, and I get this still less than. This side's all cleaned up and combined. This is too, but we've got variables on both sides. So I'm going to move all the variables to one side, and it would have been okay to move them to the right. And I'm left with 15x minus 50 is less than negative 70. At 50, 15x is less than negative 20. Divide both sides by, oops, did you see my mistake? 10x minus 5x is 5x, not 15x. I'm sorry, guys. So we're going to divide both sides by 5. And I get x is, again, I haven't multiplied or divided by a negative, and I'm going to get x is less than negative 4. I'm going to go to negative 4, put an open circle, and then if it's less than, it's all these numbers down here. Okay, give some of those problems a try. These are the same as solving equations, except when you multiply or divide by a negative. That's the only difference. Good luck.